Okay, section 4.8, complex numbers, and we're introducing what is called the imaginary number. So up until today, when we tried to take the square root of -9, we cannot think of two numbers that you multiply by themselves to give us a negative value, correct? The square root of 9 is 3, because we can do 3 times 3 to get 9, and we can do -3 times -3 to get 9. But can you find a number that you can multiply by itself to get a negative answer? And no, we cannot. So, what has been introduced is the imaginary unit I. So what we can do here is we can introduce this definition by making this tiny little change, I squared equals -1, which means I equals the square root of -1. By adding that tiny little definition, we now have opened up an infinite number of quadratics that we had to stop in our solution because we couldn't go any further. So now we can. All right, so I squared equals -1. That means I equals the square root of -1. So this, when you do your homework, should be at the top of your homework. I squared equals -1, and I equals the square root of -1. So the example you see here is the square root of -5. So the way that we are going to write this out is we are going to say the square root of -5 is equal to the square root of 5 times the square root of -1. Well, the square root of 5 is not a perfect square, so we have to leave that in root form. But what is the square root of -1 equal to? It's I. So we would write this as I root 5. That is what the square root of -5 is equal to. And they're showing it over here with the square root of -a. That is the square root of -1 times the square root of a, which is I root a. Take a second, make sure you have this in your notes. Yes?
Can you think of like -9, usually it's square root 3i or just 2i?
Well, it wouldn't be square root anymore, right? It would be 3. That root would be gone. Generally, I ask you to put the I first, because when you put it after the root, sometimes students put it right under the root. It needs to be outside of the root. So you should practice it by writing I, then the root. Okay? All right. Any other questions on this page? Okay. Moving on. All right. So now we have a couple of things we have to practice. First off, we have to practice introducing this imaginary unit I. And the second thing we have to practice is simplifying roots, which we have not pushed ourselves on any of our problems yet. So we're going to start with just simplifying the square root of 18. No negative. To simplified root form. Does anybody remember how to do this?
Don't you take like a factor? Like
Factor
it's like a square root of the factor.
No,
whatever left over.
it'd be 9 and 2, and then 9 breaks down to 3 and 3.
So what you want to do is you want to think to see if there are any factors of this number that are perfect squares. So what are our perfect squares?
4.
Perfect squares. Let's start with the lowest. 1 squared is
1.
1. 2 squared is 3 squared.
1.
4.
16.
5. 6.
36.
7.
49.
8.
64.
9.
81.
10.
100.
11.
121?
Oh, we're still going. 12.
144.
13.
169.
169. 14.
That was pretty good.
Not bad. 196. 15. 225. Okay.
Should we like memorize 215?
You really should. You really should know your perfect squares. So you did pretty well. Pretty well up to 13. That's not bad. All right. So you want to look at 18. What are the factors of 18 that includes the biggest perfect square? The biggest one you can do.
9 and 2?
Yep. Square root of 9 and the square root of 2. And the square root of 9 is what?
3.
That is 3. So root 18 simplifies to 3 root 2. Okay? So now, when we do our quadratic formula, we're going to be simplifying those roots a little further, algebraically. All right, so now let's do this with the square root of negative 18. So now I will have the square root of 9 times the square root of 2 times what? The square root of negative 1. Because these three things inside the root should multiply to negative 18. So here, this becomes 3, root 2, and then the I. And based on Mackenzie's question, we know we want to put that I in front, so we would write 3I root 2.
Do you have to write the I like you are with like almost top of the triangle? It's just a normal I.
No, you can write whatever I, you can make a little hook if you want to. Just make sure I can read it.
How come you can't do it in front of the screen?
Oh, you can. Just, that looks weird. It just looks weird. Yes, I, 3. It's not wrong. It's not wrong. All right, so right now at your desk, you're doing the next 3. I did. Oh, okay. And
Why?
Are you going to fall asleep if I turn myself? No.
Maybe.
Maybe.
I got you.
Thank you. Thank you. All right. You're doing these 3 at your desk. There we go. All right. The key thing to remember when you are factoring these is that we want to factor out the biggest factor that is a perfect square. So, what is the biggest factor of 12 that is a perfect square? Right, so let's remember it is the square root of 4 times the square root of 3 times what? The square root of negative 1. Square root of 4 is 2. Root 3 we can't simplify any further, and what's the square root of negative 1? So our answer is 2I root 3. Okay? All right, well, what's the biggest factor of 25 that is a perfect square? It is 25. The biggest factor of 25 that is a perfect square is 25. So we write root 25 times root negative 1. The square root of 25 is 5. Square root of negative 1 is? So our answer is 5. Okay? And here, biggest factor of 7 that is a perfect square. So we have to write this as root 7 times root negative 1, which is root 7 times what? I. So we put that I in front and we get I root 7. Okay? Questions there? Okay, let's move on. Okay. So now, we are going to have answers. Remember when we do quadratic formula, we get something like 2 plus or minus the square root of 10 all over 3. So we're used to seeing quadratic formula solutions that look like this. Well now, if that 10 is a negative 10 instead, then we are going to get an imaginary answer over here. So, there are times when our real numbers have to be added and subtracted to our imaginary numbers, and we call that a complex number. A complex number is written as A plus or minus BI. Where A and B are numbers that are not equal to 0, and we call this the real part, and we call this the imaginary part, just as they show later. All right, so if I have A plus BI, and B is equal to 0, well, that means that I don't have any I, correct? I'll give you a second to write down. I would write down this, and I would write down these 3 pieces of information. Real numbers, imaginary numbers, and pure imaginary numbers. I'll stop talking for a minute. All right, so they took our classification of A plus BI a little bit further, and they said, well, if B is 0, and I don't have any imaginary part, and I only have the real part, so real numbers are when B equals 0. Imaginary numbers are when we have an A and a B, and B does not equal 0. So we have something like 2 plus 3i. And then pure imaginary numbers would be if the A equals 0, which means we have no real parts, and we only have the imaginary. Okay? All right, let's see what we're going to do with these. Sometimes you will be asked to plot the imaginary number, the complex number, on the complex number plane. So this looks just like our xy plane, except we rename the axis. So you see in the picture, we name the x-axis the real axis, and we name the y the imaginary. And it's just as easy to graph on here as it is on the xy plane. It's just if we have, for example, the one that they have done is 3 minus 2i. So to rebuild what they've done here, they went over 3 in the real, and they went down 2 in the imaginary. So we have going over to 3 here, and going down to -2. And then if you are asked to find the absolute value of a complex number, then we are asked to find the hypotenuse of this triangle. So just like they have in the picture, and we just use Pythagorean theorem to do that. So the absolute value of 3 minus 2i, that's an absolute value, equals the square root of 3 squared plus 2 squared. The square root of 13 is the absolute value of 3 minus 2i. Notice that I wrote plus 2 squared. When I square that negative, it's going to become positive, so I don't even bother writing it in as a negative. Okay? So you may be plotting some on the complex number plane, and you may be asked to find the absolute value of a complex number. All right. So what are the graph and the absolute value of this number? So right now I want you to sketch it. We have our axes. We have real and imaginary. And we go -5 in the real. Here, -5 in the real, and +3 in the imaginary. There. So, this is -5 plus 3i, and the absolute value of -5 plus 3i, we will just do the square root of 5 squared plus 3 squared. That's the square root of 25 plus 9, or the square root of what?
How can we not do negative? Oh, yes.
Because I'm going to square it. The reason I don't do negative, I'm finding that hypotenuse, so I could put -5 and then square it, but it's going to come out to be the positive anyway. So it's kind of good not to even toss that negative.
34.
Thank you. Square root of 34 is our absolute value of the number. Okay? Are we okay with that? Okay. We don't need the extra practice on those. We'll be okay. All right. Adding and subtracting complex numbers. Okay, so write yourself a little note. Add/subtract. Oops. One subtract. Reals with reals. and imaginaries with imaginaries. So when we are adding and subtracting complex numbers, you add real numbers to real numbers and imaginary numbers to imaginary numbers. It's like combining like terms. Okay? So if I have 4 minus 3i plus negative 4 plus 3i, then I'm going to add the reals, which will be what? 4 plus negative 4, giving me 0. And then I'm going to add the imaginary. And I'm going to get negative 3i plus positive 3i, and I'm going to get what? 0. So the sum of these two is 0. You could write 0 plus 0i if you wanted to, but you didn't have to, because they both cancel out. Okay? Adding and subtracting, reals with reals, imaginaries with imaginaries. So, what I want you to do, you don't have to do all 4. I want you to do A and C. A, if it's too small, is 7 minus 2i plus negative 3 plus I. And B is 8 plus 6i minus 8 minus. All right, so I've shown another way that you can set it up so that you do this properly. We're going to combine our like terms, so our reals with reals. 7 plus negative 3 is 4. And then negative 2i plus I is negative 1i. So we get 4 minus I. All right, and down here I've connected my reals and my imaginary. 8, remember you're subtracting this time. Minus 8 is 0. And 6i minus negative 6i, what am I doing? I'm adding, so that is 12i. All right, products. Multiplying complex numbers. So, when you're dealing with complex numbers, think about fractions. I cannot add fractions unless I have a common denominator, so with adding complex numbers, you add the things that are alike. The reals and the reals, the imaginary and the imaginary. But, when I multiply fractions, I can just multiply any two fractions. Same thing here, I can distribute this 3i through both of the terms in the second factor. So 3i times negative 5 would be what? Yes, negative 15i, and then plus, not just 6i, 6i squared. Put a big star here. Here is the one thing you need to remember. What is I squared equal to? Negative 1. I squared equals negative 1. So when you have an I squared in your answer, you're not done yet. This will be negative 15i plus 6 times negative 1.
So negative 15i minus 6.
Which generally we put the real one first. Negative 6 minus 15i.
Do you have to do all?
No. No.
Wait, what just happened?
I squared is negative 1. So you have my figures put in negative 1.
Right. Remember we said I was the square root of negative 1, so I squared is negative 1. Okay? So if there is an I squared in your answer, you are not done. You need to replace that I squared with negative 1. All right. And let's just do B. Here we have 2 minus 3i.
Will you FOIL this?
Yes.
Okay.
4 plus 5i. And yes, it's 2 binomial. So we are FOILing. First outer inner last. First is 2 times 4, giving me. Thank you.
Are we going to on?
Yeah, I'm going to do it out loud. I'm going to do 2 times 5i. And I, inner, minus 12i, right? And then last,
Minus 16i squared.
there we go. All right, so our like terms are going to be here. We need to combine those. 10i minus 12i gives me what?
Negative 2i.
Negative 2i. And,
That'd be 16.
right, we have negative 15 times I squared. Well, I squared is negative 1. So I have negative 15 times negative 1, which is what? Nope, 15. Not adding, not adding. So now, I have another set of like terms. 8 plus 15 is what?
23.
So, my answer is going to be,
23 minus 2i.
that is correct, 23 minus 2i. You might want to set this up as neatly as you can so you don't leave out any parts. We FOIL. We combine the like terms from the i's. We replace an I squared with negative 1, and then we combine the like squared of the real numbers. Okay? You'll have a good bit of that on the homework tonight. Yeah, I'm not going to do that one right now. I'm not going to do that one right now. All right, we're going to save those two for tomorrow.
Okay.